This tutorial will walk you through Climate Consultant 6.0. Climate Consultant is a wonderful free program that takes Energy Plus climate data and organizes it into user-friendly graphic representations. It also provides a lot of user control over those representations, and even provides design guidelines based on your climate, so that architects and building designers and engineers and students can all be very aware of their precise location and propose design strategies that are appropriate for that climate. When you first open Climate Consultant, there's a screen that talks about the new features in Build 6. I highly recommend reading through this screen and familiarizing yourself with some of the language and features. If you click the Next button, you can navigate to the next screen, which are the instructions, and again, I highly recommend taking the time to read through the instructions, including clicking on the links. In order to begin using Climate Consultant, you will need to have a weather file. So you can click on the link here, which will take you to the Energy Design Tools webpage, where you can access links to many tutorials, or you can simply go into your web browser and type energyplus.net, which will bring you to the Department of Energy Energy Plus website. Then click on the Weather tab and navigate through the menus to find the location for which your project is located. If you find yourself with options, so here are two weather files for Reno Tahoe International Airport. One of them is a TMY file and one is a TMY3. TMY stands for Typical Meteorological Year, and the numbers indicate the version. So TMY would be the oldest, TMY2 second generation, and TMY3 third generation. So you always want to select the highest number available to you, as that's the most recent weather data. For use with Climate Consultant, we want to download the EPW file. Go ahead and save this either into your project or into the Climate Consultant Climate Data folder. You can leave the Energy Plus website and return back to Climate Consultant. You'll now come to a screen where you can either start a new project or continue with a previous session. We're going to start a new project. For this demonstration, I'm going to use a small non-residential building with imperial units, and now I want to open that EPW weather data file that I just downloaded. Select the EPW file, click OK, and you'll notice that the screen changes to give you a summary of the weather data. Climate Consultant is taking the EPW file, which is 8,760 hours over a year of weather data, and organizing it into a very user-friendly package. If you click the Next button on the next screen, we get to select our comfort zone. The Comfort Model screen allows you to choose which code or standard you'd like to use to control how the human thermal comfort zone is defined. A detailed description of each option is shown here. Unless you're working with a residential building in California or a naturally ventilated building, in which case you would use the Adaptive Comfort Model, I would recommend using the ASHRAE Standard 55 Comfort Model. As you become a more advanced user of Climate Consultant, you may choose to modify some of the inputs on the criteria screen, such as modifying the clothing or metabolism settings to match your project type, the activity level, and the users. For now, let's just proceed with the default values. Climate Consultant prepares 17 different types of charts, which you can see labeled by name in the Charts pull-down menu. You can either navigate between the charts here or by clicking the Next and Back buttons. Every screen will have a legend in the upper left corner, and then we'll have some options that you can control in the lower left corner. Most of the graphic representation in Climate Consultant will also depict the comfort zone. In this case, the comfort zone is depicted with these two gray swatches, the summer and winter comfort zones, and you can see them across the graphic here. This makes it really easy for us to understand the data shown on each chart in relation to human comfort. So in this chart, it's quite clear that the majority of the hours in Reno, Nevada are well below the comfort zone, with much fewer hours above the comfort zone. So we would know that this is a heating-dominated climate. Many of the charts are self-explanatory, but I will spend a little time going over a couple of the charts in greater detail. For example, the monthly diurnal averages. This chart is compiling several variables: dry bulb temperature, our outside air temperature; wet bulb temperature, which takes humidity into account by measuring the effects of evaporation; and then also solar radiation, global horizontal, direct normal, and diffuse solar radiation. Again, we have some options to modify this chart. One of the things that I like about this chart is that you can see some of the thermal lag effects. So at this point, this time of day in June is when the most solar direct normal radiation is available to us, and yet we see that the hottest time of day is actually several hours later, so we're seeing that thermal lag effect. We also can see that the dry bulb curves are up here, and the wet bulb curves are down lower, and the greater the difference between those curves, the lower the humidity is. As those curves get closer together, the higher the relative humidity. The radiation range chart could come in handy if you were designing a solar photovoltaic or solar thermal system, as you can tilt the surfaces, watch the chart update dynamically, and you can change the bearing angle from south by entering positive values for west or negative values for east. The illumination range graph gives us information about available solar radiation, but this time it's in lighting units instead of energy units. So notice here that the units are given to us in foot candles. So this chart would be good for daylighting design. I'm going to quickly browse through the next couple of charts. Ground temperature would be a helpful chart if you were looking at foundation design. The dry bulb and relative humidity graphs do a great job of depicting the inverse relationship between temperature and relative humidity. So as one increases, the other decreases respectively. The sun shading chart is one of the most useful charts available to us in Climate Consultant. It does a number of things. First of all, it plots the hours of the year, color-coded by those that are above the comfort zone, within the comfort zone, and below the comfort zone. Here, we are seeing a lot of blue, indicating that the majority of the hours from December to June 21st are well below the thermal comfort zone. And we're starting to see, as we get into the summer months, June, that we do have some hours above the comfort zone. So this is a nice hybrid graph which is showing us thermal comfort and sun position simultaneously. If I change to look at the summer and fall months, we'll see an inversion where the majority of the hours are actually above or within the comfort zone. This chart can actually be used to help design your shading strategy. If I click on the Display Shading Calculator button, you'll get a little menu which gives you instructions on how to use the shading calculator. I would recommend you pause and take a moment to read that. The way that this graph works is that you pull down this open circle, and as you do, the area that turns to gray is indicating what would be shaded by a horizontal shading device at this given angle. So with an angle of 80 degrees, which is measured from the bottom of the windowsill If you projected a horizontal line, that would be 0, and you would rotate up from that horizontal line. When you got to vertical, that would be an angle of 90. So an 80-degree solar shade would be very close to the vertical wall, so this is a relatively small horizontal projection. As I pull down, now I'm at 70 degrees. 60 degrees, 50 degrees, and probably somewhere in here in the 45-degree range would be an acceptable angle for me to design my horizontal shading devices in order to put the window in shade during the majority of these overheated times. I can do a similar thing with the left and right sides. By grabbing on the open circle, I can drag in from the right or left, and this would give me an indication of vertical fins that I might like to design for my south-facing exposure. So perhaps in the east, I don't necessarily need vertical fins. So the horizontal shading device is doing a sufficient job of blocking out those overheated times, but on the west I might like to block out some of this sun in order to improve the thermal comfort of the interior. So by dragging this over, I now see that at a 60-degree angle, measured from the sill, where 0 is true south, and then I could measure 60 degrees to the west. And that would give me a sufficient shading device in order to block out these additional overheated hours. Another great feature of the sun shading chart is that you can display obstructions. So these are things like vegetation, trees, neighboring buildings and structures that might actually cast shadows onto your site or your building. Click the Input Obstructions button, and you can add these obstructions based on orientation. If due south, we had a grove of trees. They could be a height of 35 feet with a distance of 15 feet from the building. We also need to input what is the lowest edge of either our solar photovoltaic array or the windowsill. So let's enter that as 4 feet and click OK. And you'll see that now the sun is actually shaded by those trees for these hours of day and these times of year. You can input additional obstructions, including buildings, a neighboring structure, or an attached structure in the case that you share a party wall. Let's say that it's 40 feet tall, and instead of entering a distance of 0, since this is a party wall, let's just enter a distance of 0.25 or 1 in order to give a little bit of distance between the structures, and click OK. And now again we will see that during these hours of the day and year that we don't need to provide architectural shading because the building adjacent is actually providing that shading for us. The sun chart, also sometimes called a sundial chart, gives us a gnomon height. This is the peg height. You would actually print this chart out and cut either a stick or a piece of paper that is this height and then attach it to this point on the sundial. And then you can move this around, and where the shadow lands, that simulates for you the angle of the sun at that time of day and time of year. So again, this would be a great tool for physical modeling, and you could again show the overheated period and make sure that through your physical model you were providing shading that would mask out direct solar heat gain during these times of the year. The psychrometric chart is one of the most useful tools that we have for visualizing climate data and for making this transition from not only just visualizing the data, but to actually coming up with design strategies. And Climate Consultant does a really wonderful job of automating that process for you. So again, I highly recommend that you read this box. So first of all, Climate Consultant is giving us recommendations for design strategies that we might use in order to provide interior comfort to our occupants. So if we sort of back out of this and turn them off by clicking on each of these, you will see a change where these dots were once green, now they are red, which means that people are not comfortable because we haven't implemented design strategies to bring those hours that are well outside of the comfort zone into the comfort zone. So I like to go sort of one at a time and see what the effects are of each. And you will see that Climate Consultant gives you a percentage of hours that are brought into the comfort zone by implementing this strategy. So all of these strategies are fairly low, less than 10% change. Until we get here to internal heat gain. So what internal heat gain means is that if we could just insulate the building to capture the heat that is actually generated from people, equipment, and lighting on the interior, we can bring 21% of these hours into the thermal comfort zone. So you might want to prioritize. Something like forced fan ventilation and natural ventilation are actually providing very little change, so you might want to turn those off. Just a couple of other things that you can modify here in the psychrometric chart. You can change the scale of the data, and then I can turn off the design strategies. I can also ask Climate Consultant to make decisions for me by asking it to show me the best design strategies. When I'm happy with my psychrometric chart and the design strategies that I've chosen to work with, I can click the Next button. I'll get a warning that not all of my hours are in the comfort zone. That's okay. Okay, so now this is also a very user-friendly menu, even though at first it might not appear so. But what Climate Consultant has done is it's giving me a ranked list of design strategies with more detail that would help to bring my building into the comfort zone. You'll notice that some of them have a little logo next to them for the 2030 palette. If I click on any of these links that have the 2030 palette logo, a new window will open, which takes me to the Architecture 2030 webpage and the Architecture 2030 palette, which again is a really wonderful resource for low energy, low impact design strategies. The wind wheel also has a number of options. And the legend is located here. So this is telling us the percentage of hours, which means the taller this bar is away from the circle, the greater the percentage of hours. This is correlating it with temperature, and again, temperature is color-coded, as we can see here. It's also correlated with relative humidity. And then we can see the wind speed. So the greater this orange arrow is, the taller the orange arrow is, the greater the wind speed. So we can start to get a sense of prevailing wind direction and gusts and heavy wind from particular directions. The Create Your Own Plot feature is a new feature in Climate Consultant 6. This allows you to create graphs to combine variables that Climate Consultant might not have done for you. You can make two graphs simultaneously. You can also select whether you want to look at monthly, daily, or hourly data. Under your variable pull-down list, you can see your options. I'm going to look at wind direction. Then I can choose, do I want average values or do I want recorded values? You can select the color and the line type. So let's say on my left axis I want to look at wind direction, and on my right axis I want to look at dry bulb temperature, average daily high. Let me change the color. Let's look again at dry bulb temperature, average daily low, change the color, and at the bottom of the screen click Display Plot. And behind my window appears the plot. So here I'm looking at wind direction, and here the left axis is giving me that direction in an angle, and here I'm looking at high temperatures and low temperatures. So you can play around with these. The last thing I would like to show you is how to output information from Climate Consultant. So one way is just to print. If I go to my File menu, Print Selection, I can choose either to print my full graphic window, which will include this entire screen with the legend and the information in the upper right corner, or I can choose to only print the graphic panel, so that will be only the image contained within this pane. And then I can hit print, either print to clipboard, to a PNG file, or I can check my page setup. I tend to use the PNG file option. I can also choose to export weather data into a comma-separated value, a CSV file, which I could open in Excel, and I could select exactly which variables or which metrics I want to include, and this makes it so that I can create my own custom graphs in Excel. And that's it for today.